Hello and welcome to Module 2 of the USF St. Petersburg Brewing Arts Program. I'm Jim Leonard and I'll be speaking to you about the section of Module 2 which is covering malting technology and the science of mashing, and I'll be speaking to you about water. So we're going to talk about water as really the focus of the module is as an overview of water as an ingredient. So we can talk about water sources, water quality reports, some water chemistry, and the mash. The textbooks we're using are both by John Palmer. The first one is How to Brew. This is a basic home brewer's Bible, basically. It tells you everything you need to know about how to brew. And so it's a very nice overview with some detailed discussions in some of the later chapters, which I'll be referring to. Then we have his book, which is about water. It's a comprehensive guide for brewers. And this water, he goes into quite a bit of technical detail about water chemistry. I'm going to try to lead you through that particular book. So we're going to talk about water as a brewing ingredient. Most beers are between 90 and 94% water. So water is the most abundant beer constituent. But water is uses more than just as an ingredient. On the industry average, there are 7 barrels of water for every barrel of beer brewed. I mean, it sounds like a lot, but other products require quite a bit of water. Like an almond, for instance, requires 1 gallon of water for an almond, which is pretty astounding. So we're going to talk about water usage, a little bit an overview of how water is used in the brewery, and then we'll get to water use as a brewing ingredient. So here's how it breaks down if you look at a brewery, the water use per department. So really looking at 25% of the water that's used in a brewery is actually in the brew house. That's where the beer is made. That's where your product is made. The rest of it is in utilities and in packaging and in cellaring. So you're going to have a lot of sanitation, a lot of glycol systems, which are cooling the fermenters. That's a water system. You have packaging, which is rinsing and sterilizing the cans and bottles. So you can see that the actual use in the brew house is 25% of the overall water usage. So small craft brewers are just beginning to explore water and wastewater reduction programs. Right now, it doesn't seem to affect them very much. The cost of the incoming water from a municipal supplier, which is a tap fee, is relatively inexpensive compared to other brewery utilities. But if you actually would factor in the cost of treatment, of physical and chemical treatment of the water and the effluent disposal costs, that means you're going to be treating the water before you can put it back into the city water supply. Then the brewers are going to be presented with the true reflection of the true and full cost of water. So water consumption and wastewater disposal remain environmental and economic hurdles that directly affect breweries and the brewing process. And anyone getting into the craft brewery industry today, they're going to have to become very much aware of their water usage. They're going to have to monitor the water usage. They're going to have to prepare a water sustainability plan, and they're going to have to look at water treatment and their effluent and really sending that water back to the city water supply. Given that said, there's a water and wastewater sustainability manual that's been prepared by organization, the Brewers Association, with a core team of Brewing Association craft brewers. And the emphasis of this manual is on the sustainability, working the sustainability into business practices. So I'm going to suggest or ask you or require you to take a look at this wastewater manual, which is available online. The wastewater manual is divided into a number of segments. The first one is a segment profile. So the segment profile is a discussion of water usage and wastewater effluent trends, including where to find information on regulatory drivers, examples of non-regulatory drivers, and risks and opportunities for cost savings. Second part is on data management. It's a guide to identify the components of water and wastewater information, establishing key performance indicators and goals, managing water and wastewater data, and benchmarking progress towards goals. Then we're going to talk about, then the manual talks about best practices. So there's a guidance on best practices to reduce water usage and wastewater generation with a focus on opportunities in the brewing process, including packaging, warehousing, utilities, food, services, and events. Then there's on-site wastewater treatment, and some of this is covered in John Palmer's book, a Comprehensive Guide for Brewers. And then there are case studies, so you'll see a number of the craft breweries that are available, that are associated with the Brewing Association, who will be talking about what they're doing in this particular area. So please look at this wastewater sustainability manual online, and some of these areas are also covered in chapters 9 and 10 of Palmer's water book. I won't be talking any more about those, but this information is something that you need to know and understand, and there'll be exam questions regarding this manual. So some reading assignments. Here are the two textbooks again. So what I'm going to be going into when I start talking about water as actually brewing ingredient, I'll be talking about the first 3 chapters in John Palmer's water book, the intro, where does your water come from, and how to read a water report. And then I would recommend that you take a look at chapter 15 of John Palmer's How to Brew book, which describes the mash pH, which is going to be the emphasis of what I'm talking about right here. It's going to lead all into the mash and monitoring and controlling that mash pH. So we're going to take a break here. I'm going to recommend that you go and take a look at these chapters in these 2 books if you haven't read them yet, and return to this lecture once you've done that.